Lastly, we're going to cover some properties of independence. If A and B events are independent, then B and A are independent. Moreover, A and B complement are independent, and so are A complement and B complement. Lastly, it's very important to note that independent is not disjoint. So we covered disjoint events before. That is when you have, say, two events, A and B. There is no intersection. Okay, so A, B, in the sample space. Okay. However, disjoint events are not the same as saying independent events, because we know that independent events is A and B, or we can write A intersection B is the product of A multiplies with B. Okay, so that's independence. Whereas disjoint is A and B is the empty set. Okay, so that's disjoint. So to give you an example, we think about event A is being a first-year student, and event B is a sophomore. Then we know that these two events are disjoint, because you cannot be a first year and a sophomore at the same time. However, they are not independent, because if I know someone is a first year, I know that the person cannot be a sophomore. Okay? So independent events are not disjoint events. They are two different definitions. Also, we want to cover mutually independent. So that's when you're talking about more than two events. So three events, A, B, C, are called mutually independent if you can look at any pair of the three, and each of the pair, they are independent from each other. So that's the first condition. That was a requirement. The second one is that when you're looking at the joint event of A and B and C, you can break it down into the probability of A times B times C. And so only if both of these two conditions are satisfied, A, B, C are mutually independent. If only the first hold but not the second, then we call A, B, C as pairwise independent, because as you can see, the first condition here is talking about each pair. Okay, so that's pairwise. But if this is also satisfied, then we call it as the mutually independent. And quickly, I'm going to cover definition or computation technique here when you have a sequence of events mutually independent. Okay, so that is when you're looking at the joint probability of all of the events, it will just become the product of all of the marginal altogether.